Okay, ladies and gents, tomorrow, listen, is quiz number 3 of quarter 3. We are almost done. As far as I'm concerned, anything we do after tomorrow, I'm going to count towards fourth quarter. Not really because of you guys, but my seniors are really cut short on time. So I've got to move, not any quicker, but I've got to start counting grades for fourth quarter soon. So your first quiz next Thursday will be for quarter 4. All right, the quarter ends on the 15th, but it's going towards quarter 4. So what I want to bring to your attention, first of all, make sure on the review, I noticed this, there should be a plus sign right here. Make sure that you guys have that. It's written throughout the whole review. That formula is written about 15 times. Just when Ms. Carver wrote it here, she forgot the plus sign, no big deal. What is highlighted in green will be given to you. At the top of the test, these 3 formulas are written. I did not write what they were, but those 3 formulas will be given to you. So the only 2 formulas you need to memorize is the arithmetic rule, to write the rule, and the geometric to write the rule. All right, for both of them, you need the first term. For one of them, you need the common difference, which you add each time, add or subtract. And for the geometric, it's what you multiply each time. Now, I wrote this little thing. Anytime you guys have a question that talks about sums, it's that funny looking E, you're going to have to find certain things. You have to find the common ratio for the geometrics, whatever. We'll talk about it in a little bit. But finding the number of terms, if you don't get the right number of terms, then your answer is not going to be correct. How do you find the correct number of terms? It's top minus bottom plus 1. How do you find the first term? You plug in the lower limit, which is the one on the bottom. And how do you find the last term? It's the upper limit. What I mean by that is if you have something like this, all right, and it tells you that n equals 5, and up here is 302. How do you know how many terms there are? It's 302 minus 5 plus 1. Guys, it's so important for you to understand, because when the numbers are big like that, far apart, you understand why you would need a formula. But think about it. If this top number was 7 and this bottom one was 3, some of you would tell me, oh, it's 4 terms. But it's not, because you're plugging in all of them. You're plugging in 3, 4, 5, 6, and 7. When you count how many that is, that's how many? 5. That's why it's top minus bottom plus 1. To find a sub 1, you plug in the lower limit. Whatever that number is, you plug into the rule, whether it's arithmetic or geometric. To find the upper, or find the last one, you plug in the upper. So just to understand the workings behind that is really important. Yes, ma'am?
Wait, is that 312 or 302?
302. Just a random number I made up. All right, so I want to go over a few. I'm not going to go over a lot in great detail because it's already worked out for you, but I want you guys to understand the workings behind this. If I give you a problem like number 1, first of all, this is in fraction form, correct? Then that means your answer should be in fractions. I think on every single question I wrote either exact, which means no decimals, or no decimals. So don't tell me that your calculator only works in decimals. I don't want to hear it. Scientific calculators, guys, no graphing. Find one before you get in here. You need to. You've had to before. So make sure we understand that. If I ask you to find the first 3 terms, you plug in 1, 2, and 3. Okay? And a question like number 2, if I give you the rule and I give you the number to plug in, if all you do is tell me this answer, say this is an 8-point question, that answer is worth like 2 points. I don't care that you guys can use your calculator. I need to see that you understand that the 16 goes here, that it goes here, that we simplify, that you understand the workings behind the sequence, not just what the number, the value is. So make sure you're showing me. The more work you show me, the better off you are. Remember, in a case like this, if you have a negative exponent, guys, if you have negative 1 to the 18th power and you plug it in like that in your calculator will tell you the answer is negative 1. Because it does the exponent first and then it multiplies by negative 1. So anytime you have negatives, make sure you put it in a hug. Right? You guys with me on that? Okay, so then we talk about writing rules. There might be a question that says write the rule or write a sub n, write the formula. That means this. Find the rule. Now, Ms. Carver worked this out. And she used my find the zero term thing, right? The y equals mx plus b. You don't have to do that. You can use the arithmetic. A sub n equals the first term plus n minus 1 times the common difference. I want the rule written like this, not like this. That's not the rule. That's you plugged in the first term and the common difference. All right, after you find out what that is, then you go ahead and distribute, combine like terms, whatever. Guys, when you get to this point, whether it be a fraction or not, you get to your rule. How do you know? How can you check and say, oh yeah, good, I'm right? If I plug in 4 for my n value, what should I get out? Negative 18. So just check it real quick. Negative 5 times 4 is negative 20 plus 2, negative 18, good to go. So then they say, what is the 975th term? You just plug in 974 for n. Right? Pretty self-explanatory. I'm going to go through a bunch of stuff. I'm going to do number 6 here in a second. I understand if you did this in your calculator, you got a super huge number. It was like 1 point something e to the, you're not going to get one of those where it's scientific notation. You will probably have a question like this where there's 2 factorials on the top and 2 on the bottom. You cannot multiply this and tell me this is the same as 60 factorial. That is not. Those are 2 separate things. If you want to write out every single thing, you want 12 times 11 times 10, 9, 8, 7, 6, 5, 4, 3, 2. And then you want to do 5, 4, 3, 2. And then on the bottom, write out the whole thing and cross out. That's fine. We stopped here at 4 factorial because we knew it was going to repeat, top and bottom. We stopped here at 7 factorial because we knew it was going to repeat, top and bottom. You just cross it out.
You need us to write that probably.
I need to see this. Yeah. And then your answer. Now, this is what I'm talking about with the sum stuff, right? You guys are going to be given the 3 formulas for the sums, but I didn't tell you what they were. So you have to be methodical and say, okay, which one am I talking about and how do I figure it out? So the first thing we look for, we have 2 sums. We have arithmetic, right? And geometric, right? How do you know the difference? By looking at them. Correct. Geometric has an exponent with a variable. What kind of function is arithmetic? It's linear. So just by looking at the function itself, you can tell if it's arithmetic or if it's geometric. Both of these are what? Arithmetic. There's no variable exponent. Just pay attention to stuff like that, guys. There's no reason to be so confused. Once you figure it out, say it was like this. What is that one? Geometric. Okay, what about if I do this? Now you know it's geometric. Is it finite or is it infinite? How do you know it's infinite? Because it's infinity on top. If it was like this, it's what? Finite. So there's 2 different formulas. You need to know which one is which. There's a bunch of problems on here that show which is which. There's a bunch we did on videos and stuff like that, so make sure you're watching. Now, every test will have a question like this. We did this on WebAssign. You guys did this in the notes, 8.2. We're going to do it again here. What is important about this? All right, they tell me this term and this term. Okay, super. But what is super important about what they told me right there? It's linear. Perfect. Why is that important? Yep, because slope is your common difference. So what they gave you here is so important. They told you the 12th term was 13. They told you the 18th term was 31. Well, what do you do with that information? You find what? The slope. So 31 minus 13 over 18 minus 12. What's 31 minus 13? 18. Divided by 18 minus 12 is 6. So what's your common difference? 3. So your common difference is 3. What do you need in order to write your formula? You need the common difference and what? The first term. Now, you can use either point that they gave you to find the first term. I always use the one that's closest, or the smaller term, the one that's closer to the first term. Which term is closer to the first term, the 12th term or the 18th? Okay, So I'm going to say a sub n equals the first term, I don't know what it is, n minus 1 times d. I'm going to use the 12th term to find the first one. How far, what term number am I using? 12, so 12 minus 1, and then my common difference. What is the 12th term? So 13 equals a sub 1 plus 33. I subtract 33 from both sides, so what's my first term? Negative 20. Did I write my rule yet? No, your rule is your first term of negative 20 plus n minus 1 times your common difference. We distribute, so negative 20 plus 3n minus 3. So your rule is a sub n equals 3n minus 23. How do you know you're right? You can plug in. Plug in 12, see if you get out 13. Plug in 18, see if you get out 31. And then if the question says, now find the whatever term, then you plug in. All right, we did 8.2. We did a question like this. It's also on WebAssign, so make sure you guys are back at that stuff. How do you figure out the common ratio if you're given a bunch of numbers in a row?
Divide the second term by
Second by the first, third by the second. Whatever term by the one in front of it. Remember, if your signs are alternating, what do you know your R value is? Negative, good. If your if your sequence is getting smaller, numerical value is getting smaller, that means you're multiplying by a what? By a fraction, good. If you go from 12 to 4 to 3 over 4, you know, you're dividing. It's the same as multiplying by a fraction. Okay, let's look at some others here. What else do I want to look at? I changed this one on the, yeah, let's do this one. Let's do this. What do I have this on the review? 15 is the top number? And n is 4? Okay, so, and the function is 2 times 4 to the I. So this is one of those problems that I would say, figure out which sum you're talking. Obviously it's a sum because it's that funny looking E. But is this geometric or arithmetic? It's geometric. I know it's geometric because I have a variable exponent. Is this finite? Does it have a beginning and an end? Or is it infinite? It's finite. What? Yeah, I on the review, didn't I change it?
Yeah, on the review, number 20
Yeah.
is 5 and 1.
Oh, okay, well, let's just do it like this. On my copy, I changed it because in my mind, I wanted to do something different. So a finite geometric, the sum is a sub 1 times 1 minus r to the n over 1 minus r. The hardest part about this problem is the numbers get big, but you guys have a calculator. So let's talk about the number of numbers we're talking about. What is your n value? Top minus bottom plus 1. 15 minus 4 plus 1. How many numbers total am I talking about? 12. Good. It's not 11, it's 12. So how do I find the first term? I don't plug in 1. What am I plugging in? A sub 4. Why 4? Because that's the number on the bottom that tells me to start with. So it's 2 times 4 to the 4th power. What do you multiply first? Exponents. 4 to the 4th times 2. What is it? 512. Okay. So that's your first term. And then I need to figure out the last term. So it'd be A. Do I need the last term in this one? No, I don't. I need my R value. I'm sorry. What is your R value? What's your R value? 4. That's it. Just whatever's with the exponent. Yep. Sometimes it's in parentheses, sometimes it's not. So now let's go ahead and plug in. So I know my first term, we just said, was 512. I'm going to go ahead and put it over 1 because I know I have a fraction. And then I'm going to set this up and say 1 minus what? 4 to the what power? To the 12th power? over 1 minus 4, correct? That's the pre-calc part of understanding this is a geometric finite sequence. Now the rest is you guys with algebra and computation. What do you compute first? What's the first thing you're going to do? Okay, inside the fraction, what?
4 to the 12.
Correct. So it's 1 minus. If you can't read the number, it's fine. Just read the numbers out to me. It's a big number. Relax.
167.
Hold on. 1, 6, 7.
7, 216.
Okay, so that says 16,777,216.
You want me to read to like that, or like?
Well, some people can and some people can't. If you can, great. If not, no big deal. So now I have, okay, 512 over 1. When I subtract 1 minus, it gives me what? Negative 16,777,215 over what? Negative 3. Now this, it's going to say exact value. It's going to say no decimals. So you have to keep this as fractions. First thing I see, a negative divided by a negative is a, okay, good. So let's see if we can simplify it all. Does 512 divide by 3? Nice and pretty. Do 512 divided by 3. What do you guys get?
170.3.
Point? Nope, don't want it. What about 16,777,215? Does that divide by 3? Whole number. What is it? 5,592,405? Okay, and then we times that by what? 512? This is 512. So when you multiply those two together, what do you guys get? 2 864 million.
No. Oh, okay.
63. Okay.
311,000.
311,000. 360. Okay. Ginormous number. But who cares? It is okay that it is a large number. You guys might get a really big number. You might get this number like 1 over. It's a really, really, really small number. I'm just saying you've got to be able to use your calculators. Don't freak out. All right? Can we do that, please? I don't feel confident that you guys are going to do that for me. All right, let's look at this last one. Every single version of every single test will have one of these. We did this. This is 8.3. We did this on WebAssign. It's on a video. You guys can figure this out. This is the exact same concept as number 6, where they gave me the third term being what number? 5. And they told me the 8th term is 1 over 625. I have to find the first term and I have to find R before I can do anything else. Can I just put those numbers together and find the slope? Why? This is not linear, it's geometric. This is an exponential function, so we cannot do that. So let's talk about our exponential functions. A sub n equals first term times r to the n minus 1. Let's find the r first.
You plug it in.
We're going to plug in. Which term is further away from the first term? The 8th term or the 3rd term? The 8th term. You always put the one farther away outside. I'll show you why in a second. So I have then the 3rd term. What is my exponent?
1 over 6.
No.
Oh, wait, sorry.
It's my exponent. How far is it from 8 to 3?
5.
It's 5 spaces. Your exponent is the amount of spaces away. The reason you put the term further away from 1 on the outside is because you'll keep your exponent positive. No, not for... It's the exact same way we did it last week. We're trying to find that n minus 1 value. We're not trying to find, 5 is not our term number.
Yeah, but
We're not putting it in the formula. We're finding the value here of n minus 1. So when we work this out, guys, a sub 8 is 1 over 625 equals 5 times r to the 5th power. How do we solve? How do you get r by itself? Divide by 5, good. Keep change flip. So r to the 5th power equals, if I keep change flip, it's 1 over 625 times 1 over 5. It's going to be 1 over 3125. How do I find just r? Take the 5th root. Now, guys, if I have an even root, what do I have to put in front of my answer? Plus or minus. Is this an even root or an odd one? It's odd. So figure out what number times itself 5 times gives you 3125. Start small. Start with 2 to the 5th, 3 to the 5th, 4 to the 5th. What do you get? Correct. It's 5. So your ratio, your R value, is 1/5. Yep.
how do you know? I think I'm missing something. How do you know, like, to put a
You always put the one that's furthest away from the first term on the outside because you want your exponent to be positive. Like 8 minus 3 is 5, right? If you put it the other way around, you get 3 minus 8, which is negative 5. Yep, now you just plug in one of them. Doesn't matter which one. I'm going to use a sub 3 and 5 because they're prettier. So I'm going to say, okay, I'm going to use the third term. First term times r to the n minus 1. Well, what is the third term? 5 equals the first term, which I don't know, times r, I do know, is 1 over 5. And what place is 5? It's the third, so to the 3 minus 1. Whatever this term number is, that's what goes in for n. So now this is easy. What is 1 over 5 squared? 1 over 25? And then what do you do to both sides? Multiply by 25? So your first term is 125. So now you have both things you need to write your rule. So your rule that you would write is a sub n equals first term, which is 125, times your r to the n minus 1. And then I might say, what's the 10th term? So you got to plug in 10. And again, that's a fraction, so you need to leave it as a fraction. But you do the same thing every time. It's the exact same process, no matter what term numbers I give you, anything like that. You find r first. How do you do that? You put the term furthest away from the first term on the outside, the other one on the inside. The spaces away is the exponent. Solve that, and then you use one of the term numbers and the actual term to plug in to find a. Doesn't matter which one. How do we feel? In other classes, I talked about possibly doing a calculator, non-calculator portion. I decided to just keep it all together. But you guys have to have a scientific calculator. Don't come in here with a graphing and then say, I don't have anything else. I have 2 that you can borrow, but I am not helping you with the calculator during the test. Are you with me? Okay, I'll put this up.